Hello everyone, I am Anuj Verma and I am creating this video for my CSC 578 final project submission. The project is a Kaggle competition for which the task is to predict the temperature of the next hour based on the climate conditions and temperature over the last 24 hours. This competition is a multivariate temperature forecasting problem. The first thing that we needed to do is to convert my data in a format that is supported by the RNNs or the recurrent neural networks. So this function series to supervised, it was created to convert a time series, the data that is given to us, as a supervised learning data set, so that we can use this data in our RNN models, or more specifically in LSTM models. The function is referenced from this website, Machine Learning Mastery, and it is updated as per my need to convert the data. So the data that this function gives me, is in the form of features and target variables, and these are the shapes of the feature and target variables returned by the function. So I need to convert this or reshape this data such that it is acceptable by the LSTM models or the RNN models. Okay, so this is the overall approach that I am using for this project. The strategy is as defined in these steps. So the first step will be to create a trimmed version of my data set so that it makes easier for me to experiment over various network architectures and parameters with less time, of course. The second step is to create various network architectures and run the model to test the performance. The third one is to change various parameters of the networks based on some of the best models taken or chosen from the above step 2. So I will change the parameters of those chosen models based on batch size, number of epochs, or activation functions that are necessary, or the optimizers, and then select the best parameters. The fourth step is to split my main training data, the data that we are given, into train and validation sets to run the models. So I am not going to touch the test data. The test data will be used just for the predictions from my final model. Select few top model architectures. This is step 5. Select few top model architectures and fit train data from above steps and validate the performance with validation set and create validation set. Then the sixth step says select the best model with optimal parameters so that I don't overfit my model based on the above results. Then train the best model on whole training data without validating it and make the predictions on test data. And then I will submit in the 8th step. I will submit the file, the prediction file, in the format specified and required. So the first step is create trimmed version of data. In this step, I have created the data set with 10,000 samples only taken from the training with a taken randomly from the training set. So these 10,000 samples were then split into train and test data to make my models, kind of test my models. Then the second step is to create various network architectures and test the performance. So before creating the various architectures, I need to change my data from the and train data created above as well. So I had to reshape the data in the format required by LSTM models. So the step 2 is creating various network architectures and testing their performance. In this step, I have mostly stick to LSTM models because they are kind of the state of art models right now in recurrent neural networks. I was testing uh, a lot of combinations with LSTM. So the base model that I took was with the LSTM, simple LSTM model with one activation node, and then I tried with a lot of different combinations containing the uh, including stacking the LSTM with single activation node, or stacking LSTM with multiple uh, activation nodes, using bidirectional LSTMs, using combining bidirectional LSTM with the normal LSTM, combining LSTM models or the stack of LSTMs with dense layers, and using the dropout, using regularizations so that I don't overfit my model. And there were a lot of different combinations tried. Out of all of those combinations, I chose 3 models based on their performance, and these models are then further tuned for the parameters. The batch size, different batch sizes were tried, then different epochs were tried, number of epochs were tried, different I mainly tried 2 optimizers, SGD and Adam. The SGD was tried with learning rate 0.01, momentum 0.9, decay 0.0001, and the Adam. So this is the best SGD model that I was able to come up with out of different combinations for momentum and decay and learning rate, and this is the best Adam model which I was able to come up with out of different combinations for learning rate and decay. The Adam one gave me a little better results than the SGD. They were both comparable, similar, but I would stick with Adam from now on. Okay, so the next step is to split the main training data into train and validation set, and then run all of 3 models. So when I ran all of 3 models, they gave me again similar results, but since my model 3, so this is my model 3, select top 3 model architectures and then fit train data and check performance on validation data. So these are my models. The first model that was chosen is using 2 LSTMs with 50 activation nodes each, and then just one dense layer with output. And I am not using any activation functions. The default activations were used in this one. Then the second model, which gave me good results, is the bidirectional with LSTM 50 nodes, and then LSTM with 50 nodes, and then the dense one. So it is simply the extension of the first model with one bidirectional LSTM. And then the next one is with 2 bidirectional LSTMs. One of them have 100 activation nodes with 50 activation nodes. The second one is 50 activation. Then a simple LSTM model, and then one dense layer with 100 nodes, and then one dense layer with the single node for the output. And I applied dropout and regularizer, L2 regularization in this to avoid overfitting my models. These gave me all of the 3 gave me similar kind of results. but I would go for the first model because of the simplicity of the model, because it is much simpler than the below models, and also I have to train less number of parameters in that model. So I trained the model on my train set, the train part of my train set, and then tested it on the validation part taken from the train set, and then I applied the model and predicted the values for my testing set, which was required to predict, and I got the accuracy, or not the accuracy, I got the mean absolute error of 0.489, which put me on 10th position in the private board, on the private leaderboard. So here I am. Yep, that's it for this video. Thank you.